everyone, welcome back to my video. Today I'm going to explain about number system and representation, subtopic 1.2 under computer system. So at the end of this topic, you should be able to explain what is data representation in computer, and you should be able to describe why hexadecimal notation is used. As you all know, a computer is built with many connections and components which are used to transfer and store data as well as communicate with other components. Most of that storing, transferring and communicating happens with digital electronics. So as you can see here, these are some of the components that we have in our computer, but this picture show you the component for a personal computer. Okay, we have a motherboard that we have on here. We have a lot of circuit, electrical circuit. Okay, and this is power supply that will provide the electricity for our computer. So, how does a computer represent data? As I mentioned before, since computers are electrical devices, they recognize only two discrete electrical states. That is, there are on and off. Therefore, computer use two binary digits 1 and 0 to represent those two electrical states. Digit 1 is used to represent on, while digit 0 to represent state off. So on and off states involved in a component named transistor. Okay, transistor is a fundamental building block for all digital electronic gadgets, including computers. And transistors are used as a micro switch that can be either switch on or switch off. You can find a lot of transistor in our processor, in our laptop, or in our personal computer CPU, or sometimes we call it a processor. Okay, we have a lot of transistor on that component. So what is meant by on and off? Off is when no current is flowing through. Okay, no current is flowing through, okay, in the circuit. And on is when current flows through the circuit. Okay, on is when we have current flows through the circuit. This picture shows in terms of light bulb. So how data is represented in computer? As we mentioned before, computer only recognize two states, on and off. So the smallest unit that a computer can process is 0 or 1. It is known as bit. Okay, it is known as bit. Bit is a short for binary digit. Okay, bit is short for binary digit. Okay, B-N-I-T. And a bit represents an electrical state on or off. Okay, 1 for on and bit 0 represents off. Then besides bit, byte, okay, that we use the term byte, okay, is 8 bits that are grouped together as a unit. Okay, a collection of 8 bits we call a byte. What is a byte? A byte represents one character such as a digit, a letter, a punctuation mark, or any symbol in computer. Any symbol means you can see all the whatever you have on the keyboard. Okay, so a byte is used to represent that character. Okay, symbols such as dollar sign, percentage, ampersand, star. Okay, everything will be represented by a byte. So examples here. Okay, combination of bits, that is 8 bits. Okay, such as this 11000101 represents small letter e, while 10000101 represents E, capital letter. E with capital letter. So how do we know this? Okay, how do we know this representation? We can refer to conversion table. Okay, we can refer to a conversion table in next slide. Before that, we take a look at the summary of bit and byte. Okay, bit is only one digit, whether it is 1 for on or 0 for off, while byte is combination of 8 bits. So maybe the combination is like this. Okay, 00110101. Okay, the 0 digit is represent off state. Okay, off state. Okay, here another illustration to make sure that you understand what is the difference between bit and byte. Here are the conversion table that I mentioned before. Okay, we have this conversion table. If you want to see what is used to represent all the character that we have on our keyboard. Okay, as the example I mentioned before, small e and capital E. Okay, small e and capital E is here. So binary digit use is like this, while capital letter, the binary digit use is here. Okay, like this. Actually, this table, this conversion table, show you the decimal value, the binary value, octal value, and hexadecimal value for each symbol. Okay, ASCII is the standard used around the world that we will go detail in our next subtopic. Okay, 1.3 later on. So actually, we have 4 basic number that involve in computer: decimal, binary, octal, and hexa. But for our syllabus, we just focus on 3 number system, that is decimal, binary, and hexadecimal. Next, let's look at the units that we use to represent memory, or in other words, is our storage. Hope you guys know that computer stores all data and information only in binary digital form. Okay, so no matter what we see, okay, with our eyes, we can see text, photo, audio, and video when we use the computer, but actually inside the computer it is comprised only collections of ones and zero. Actually behind it, the picture, the photo, the audio, text is comprised only collections of ones and zeros. We could see the text, the photo, audio, or listen to the audio or video because of our operating system. Okay, because of our operating system that present the data our text, video and audio in a graphical format, okay, in GUI environment. GUI is graphical user interface environment, okay, which we are all familiar with, okay. So this is what I mean, okay. We as a user, computer user, we will see this type of data, okay, image, document, data, music, video, and the website that we see, okay. We can see whatever that we understand, okay. We can see what we understand, but actually behind it, okay, whatever we store inside the computer is a combination of 0 and 1 only, okay. Okay, behind all the image we see here is actually consists of 1s and 0 only. This is what computer understand. This is what we understand, okay. So the memory or storage capacity is represented in unit which based on bits and bytes. Okay, everything that we store in our computer or smartphone is represented in units, okay, which is based on bits and bytes. So the unit that involved is kilobyte, megabyte, gigabyte, terabyte, and petabyte. But do not get confused with this one, okay. How about kilobits? Okay, we have kilobits, megabits, and also gigabits. This is an extra information for you guys, okay. Kilobits, megabits, and gigabits are units of data used for measuring data transfer rate, okay. It is used, if it is spelled as BITS, bits, means it is to measure data transfer rate, okay. It refers to bits per second. Usually we can find this measurement when you want to buy a modem, okay. When you want to buy a modem, you make sure that you want to make sure how fast it can transfer data, okay, transfer data. So usually we have this 56 kilobit per second modem, okay. So if the spelling is like this, bits, okay, bits, it is referred to the data transfer rate. So compared to this one is in byte, okay, based on bytes. So we have kilobyte, megabyte, gigabyte, terabyte, and petabyte is used for storage capacity. Is unit used for storage capacity. It's different, right? Okay, it's different. Okay, kilobyte, this one is kilobits. Okay, hope you guys get some new knowledge here. But for those who already know, it's good for you. Okay, let's see how much is 1 kilobyte. For 1 kilobyte, we have 1024 bytes. Okay, that is equal to 2 to the power of 10 bytes. And in 1 megabyte, we have 1024 kilobyte. Okay, which is equal to 2 to the power of 20 bytes. 2 to the power of 20 bytes. For 1 gigabyte, we have 1024 megabyte, which is equal to 2 to the power of 30 bytes. 1 terabyte, we have 1024 gigabyte, which is equal to 2 to the power of 40 bytes. And the largest measurement, the largest capacity is in petabyte units. Okay, petabyte unit, PB. It consists of 1024 terabyte, which is equal to 2 to the power of 50 bytes. This is a lot. Okay, this is a lot. So here is some extra information for you guys. Okay, the storage capacity in storage device. Okay, storage capacity in our storage device that you may need to know. Okay, floppy disk maybe does not exist anymore. Okay, floppy disk. Maybe some of you never see this floppy disk nowadays. Okay, but for CD-ROM, DVD-ROM, Blu-ray, maybe you are familiar with these things. These 3, 4 hard drive is already in our computer or laptop. Okay, we have hard disk drive. So we have 8 terabyte capacity for hard drive now. For the CDs, it is in the unit, in gigabyte unit. Okay, still in gigabyte unit. And magnetic tape, maybe it is used in factories. Okay, in big company to store or do their backup. Okay, their backup, and it can store up to 185 terabyte. After that, you should know how to convert between those units. Okay, you should know how to convert between those units. To convert from bigger to smaller unit, the blue one here. Okay, if you need to convert from bigger to smaller unit, you should multiply the value. You should multiply the value given to you with 1024. Okay, if the question gives you the unit in gigabyte, and you need to convert it to kilobyte, means you need to multiply 1024 2 times. 1, 2. Okay, multiply 2 times. How about smaller unit to bigger unit? Okay, from, let's say, from byte to megabyte. Okay, the question gives to you to convert from byte to megabyte, so you need to divide. Okay, divide 2 times. Divide the value 2 times with 1024. Okay, from byte divide 1024, you will get a kilobyte in kilobyte. Then you need to divide another time with 1024 to get the megabyte unit. So let's look at some example. So example 1, convert 8 GB to kilobyte. So to move from gigabyte to kilobyte, you need to multiply 2 times. Okay, 2 times. So the value given to you is 8 GB. So you multiply 8 with 1024 2 times. You will get, okay, 8,388,608 kilobyte. Okay, so remember, to convert from bigger to smaller unit, the operation is multiply. You need to use multiplication. Next example, convert 1200 megabyte to gigabyte. Okay, convert 1200 megabyte to gigabyte. So as you can see here, from megabyte to gigabyte, you just need one step only. Okay, but from small unit to a larger unit, you need to do division operation. So 1200 megabyte divide with 1024, you will get 1.17 gigabyte. 1.17 gigabyte. So remember, to convert from smaller to bigger unit, the operation involved is division. Okay, you need to divide with 1024. So with that 2 example, I will wrap up my lecture for the first part of 1.2. We will continue the second part of number system and representation in my next video. Stay tuned.